Quadratic functions part 1. This video will show you how to explain the meaning of the terms in a quadratic expression that represents the height of a falling object. You'll also learn how to use tables, graphs, and equations to represent the height of a falling object. So gravity follows a quadratic function where d of t equals 16t squared, and t represents the time the object was falling. So distance fallen and the height are related. So if we know that distance is 16t squared, then we can find the height of an object by subtracting the initial height and then minus 16t squared. So let's look at some examples of these types of objects. A rock is dropped from the top floor of a 500-foot tall building. A camera captures the distance the rock traveled after each second. And here's an image of the building and where it was after each second. So if we look, we start at 0 seconds and then we go down to 5 seconds where it hits 400 feet. So between each interval of seconds, it looks like the gap between them gets bigger and bigger. So how far will the rock have fallen after 6 seconds? So we ended at 5 seconds where it was 400 feet. And if we go to 6 seconds, that gap is going to be pretty big. So we're actually not going to be able to reach all the way to 6 seconds because it's going to hit the ground first. So we can say that it's going to reach 500 feet because that's when the rock will hit the ground. And since that building was 500 feet tall, that's why it went all the way down to 500. So we can use this formula d of t equals 16t squared to find the distance the rock fell given the time. So if this was a taller building, how far would it fall after 7 seconds? Well, let's start with our equation they gave us. And since we know it's falling for 7 seconds, we'll replace t with 7. 7 squared gives us 49. And then if we multiply that by 16, we'll get a distance of 784 feet. So we know that this expression will give us the distance that the object fell. So let's say the object is dropped from a height of 906 feet. What is the height of the object 2 seconds after it is dropped? So we'll use our height function, and that says that we can find the height by taking the initial height of the object and subtracting 16t squared. So we know that the object was dropped at 906 feet, so that's our initial height. So we can replace h of 0 with 906. And then we know that the object is falling for 2 seconds. So we'll replace t with 2. And now we'll just do the math. So we know that 2 squared would give us 4. 16 times 4 gives us 64. And if we subtract that from the initial height of 906, we'll get a height of 842 feet. Write an expression representing the height of an object in feet t seconds after it is dropped. So we can take what we already put. So we know that the height will just be the initial of 906 minus 16t squared. So we just need the t, we just need to find out how long it was falling, and then we can find the height. Here are some practice problems. A rocket is launched in the air and its height in feet is modeled by a function h. Here is a graph representing h. So let's just kind of dissect each piece of this graph. So let me zoom in so we can see it better. So the y-intercept, this will tell us the initial height. So we can tell that the object was dropped at around 15 feet. And then we can also look at the vertex to find the maximum that it reached. So we can see when x was 3, that the maximum was 3 seconds. And then the y value tells us our feet. So this tells us that the maximum height is 160. And then we also have an x-intercept. And the x-intercept will tell us how long the object was in the air. So since the intercept is around 6.4, we can say that it was in the air for 6.4 seconds. Here's one more practice problem. A baseball travels d meters t seconds after being dropped from the top of a building. The distance traveled by the baseball can be modeled by the equation d equals 5t squared. So here's a table that we're going to fill in based on this function. So if the number of seconds was 0, we would replace z with 0, which would give us an answer of 0. So if we plugged in t equals 0.5, then we would square 0.5, giving us 0.25. And if we multiply that by 5, we get 1.25. Now let's plug in 1. So 1 squared is still 1, so multiplying that by 5 just gives us 5. Now let's replace it with 1.5, and 1.5 squared is 2.25. So if I multiply that by 5, we'll get 11.25. And the last one is 2 seconds, so we'll replace t with 2. 2 squared is 4, and 4 times 5 is 20. So now our table is completed. So let's go ahead and graph this table so we can just see what it looks like. So we'll start with the point 0, 0, and then 0.5, 1.25, 1, 5, 1.5, and 11.25, and then our last number is at 2, and then up to 20. So to recap everything that we've learned, the equation d equals 16t squared models the distance in feet that an object falls after t seconds, no matter what its mass is. The average rate of change will increase each second, so the object will speed up over time. And we can find the height of an object by subtracting the distance formula from our initial height of the object.